Hello, we have done the power rule, the product rule, the quotient rule, and today we are going to learn another rule. It's called the chain rule. What the chain rule is when we have a more complicated function, we call it composite function. So for dy over dx, the derivative of y equals 3u to the exponent 5 minus 2u negative 3 plus 1, and u itself is a function of x, square root x plus 1. This is just a random function. We pick it, and we are going to see if we have a function like this, how we can find the derivative. So the chain rule is h at x is two functions combined. So f at g at x. So the function f, the input is g at x. The derivative is h prime of x. We do the derivative to function f, treat the g at x as one variable, then we times the derivative of g at x. So f at g at x also sometimes it will be written as f open dot g then at x. So in Leibniz notation, dy over dx equals dy over du times du over dx. If y is a function of u and u is a function of x, then we are going to do the derivative to u first, then we do the derivative du over dx. So it's kind of du, you can cancel out, dy over dx. So it works. Now we are going to see how we are going to apply this chain rule to this example 1. So determine f prime of x using chain rule. You could use a method we used before. It's just use a power rule, then after that we do again to whatever inside the derivative. But now so you could write it as 4 minus x squared, then 1 over 2. Then you can use bring it to the front and do the derivative to whatever inside. But we want to use this chain rule and see how it works. So let g at x equals whatever under the square root, 4 minus x squared. Then f at x, we could write it as g at x to the exponent 1 over 2. So now we are going to do the derivative f prime of x equals f prime to g at x, then times g prime of x. So if we want to do the derivative to g at x, we could treat the g at x as one variable. So bring the exponent to the front, then the exponent take v1. So it will give us negative 1 over 2. Then we do the derivative to x. So g at x equals this one, do the derivative, constant, derivative is 0, negative x squared give us negative 2x. Then we subtract the g at x with 4 minus x squared. So the final answer will be, simplify negative 2 divided by 1 over 2 is negative 1. Then g at x is 4 minus x squared, negative 1 over 2, then times this negative 2 times positive 1 over 2 is negative 1 already, so only x left. So this is a f prime at x. So the final answer, we could write it as one over 2, then g at x, negative 1 over 2. So if we just find the derivative to g at x, the answer will be this one. Then the g prime of x from here is negative 2x. So if you want to find it f prime of x, you combine these two together. So this is how it works. So another way you can think, instead of using all this g at x stuff, you can think, okay, we have the function in this form, and what we are going to do is we do the derivative to the exponent. So we bring the exponent to the front. Then the exponent minus 1 is a derivative to whatever to the exponent. Then we are going to do whatever at the base. So we do the derivative 4 minus x squared. Derivative give you negative 2x. Then you simplify 1 over 2 times negative 2 give you negative. Then you get the answer. So this is another way you can think of it. It's just kind of you have a function f at x to the exponent n. Then the derivative of this one, you just bring the n to the front. Then f at x to the exponent n minus 1. Then do the derivative to f prime of x. So this is another way you can think. We want to find the derivative of y prime. What we are going to do is bring the n to the front, then exponent minus 1. Then after that, we just deal with whatever the derivative to the base. So this is another easier way to think about the chain rule. So now we are going to see the next example. So next example, actually, because we are dealing with all the f at g at x, g prime x, all the function notation. So we want to practice with function notation in order to use a chain rule while. So f at x equals 1 over x, g at x equals square root x minus 5. Determine f, open dot, then g at x is same as f at g at x. So what it means is input is g at x to f at x. So we substitute g at x to x. So what we are going to have is 1 over, then x becomes g at x is square root x minus 5. Then it's done. So it's just, I will write more steps. So equals f at input is g at x is x minus 5 now. So we are going to replace x with this square root x minus 5. Then this is done, okay? So g at f at x. So this one we are going to from inside go outside. Input is f at x is 1 over x. Then g at x is this one. The x replace it with 1 over x. So square root 1 over x minus 5. Then it's done. So g at f at 1 over 10. So from inside go outside. First input is 1 over 10 to f. So g at f 1 over 10, 1 over, replace x with 1 over 10. So reciprocal of 1 over 10 is g at 10. Then we are going to sub 10 to this g at x. So replace x with 10. We have 10 minus 5. Then the final answer is just square root 5. So we just play with function notation. So inside first, input first, and find the output, then use a new output as a new input for the next function. So this one g at 5, we sub in the 5 to function g. So equals f bracket, sub in 5 to g at x is 5 minus 5. Then do the calculation, we have f at 0. Then we sub in 0 to the function f at x, we have 1 divided by 0. We know this is undefined. So this number doesn't exist. So this is a practice with function notation, because we need this input output for the chain rule. We have so many input output. So the next one, we are going to see example 3. This one is input output, but using the table of values. So for this one, we are going to see f at g at 6. So we are going to from inside go outside first. Find the g at 6. G at 6 is 6. So f bracket input is g at 6 is 6. Then we are looking for f at x when input is 6 is -3. So this is kind of like the chain reaction, input output. So this one, f prime of 0 is input. So f prime is here, 0 is input, is this 6. Then we find for g at x, input is 6, output is 6. And this one, g prime, f at 4, f prime 4. So g prime, input is 4, f at 4. So f at x, input is 4, is 4. And f prime at x, input is 4, is 0. So g prime at 4 is 4. Then times 0 give you 0. So we just play with input output. This one, 1 over f at -7. This is f at x. -7 is 0, so it's 0. Then it is undefined. So we always from the inside go outside. Then input becomes output, then output becomes input again. Okay, so this is example 2. Just practice the function notation, input output. Example 3, using table values. Continue to practice with function notation with derivative also. So this is g at 6. The open dot is just function f at g at 6 as input. So now we are going to see the next question. Where are we going to use this to find this one is find the derivative, then after that find the derivative when x equals 3. So example 4, dy dx. We know that the Leibniz notation dy dx, if the variable is u, then we do the dy over du first, then times u over x, du over dx. So du, we can just cancel out, and we have dy dx left, but we write it in this way. It's easier for us to find the derivative, because y is in terms of u. So we are going to find the dy du. This is a polynomial, so we just do the derivative to each term. And each term is just use a power rule. Bring the exponent to the front and the exponent -1, 2 operations. So the first derivative is 3. U 5 minus 1 is 4. Minus 2 times exponent to the front. The exponent subtract 1. -3 minus 1 is -4. Constant derivative is 0. Then times derivative to x. So this one we could write it as exponent. So x plus 1 to the exponent 1 or 2. So this is bring the exponent to the front, the x plus 1 to the exponent -1 or 2. Then we do the derivative to x plus 1. So x plus 1 derivative is just 1. So we have, actually, we have more chain rules here. We just continue to do the derivative to the base again. Then we are going to subtract the u as square root x plus 1, then you have the final answer. Or you could just leave it here because it asks you just to find the value of that derivative. Okay, so this 1 or 2. Then when the value x equals 3, we are going to find u equals what? So we sub in the x equals 3 to the u square root x plus 1 is 3 plus 1 is square root 4 is 2. So in this equation, we are going to see that you only have u and x. So we just need to sub x equals 3, u equals 2 back to this expression. So sorry, I forgot one of the term. It is equals 3 times the exponent into times to the front. Okay, so we sub in this one to this equation. We are going to see what we are going to have. So dy over dx equals 3 times 5 is 15. Then times 2 to the exponent 4 minus 2 times negative 3 is positive 6. Then u 2 to the exponent negative 4. Then times 1 over 2 x plus 1 is 3 plus 1. Negative 1 over 2, then times 1, we don't have to write it there. Then continue, simplify. 15 times 2 to the exponent 6 is 15 times 16, give you 240. Then plus 6, 2 to the exponent negative 4, we could write it as 2 to the exponent 4 at the denominator, so it's 6 divided by 16, then times 1 over 2 is 4 to the exponent negative 1 over 2. Then continue, simplify. Use your calculator, is approximately 601. So this is 60.1. So this is how you find the derivative at one x value at one point. This is a tangent at that point. Okay, so this is using the chain rule to find the dy dx, then sub in the x value. Meanwhile, we find the u value because in the expression we have the u value there. So now we continue to do the next question. So if y equals function f at 2x to the exponent 5, then f prime of 64 equals negative square root 2 times pi. It asks you to find the derivative dy over dx at x equals 2. So we are going to find the dy over dx equals, we are going to let u equals input at function f at x. So 2x to the exponent 5 is our u. So y equals f at u now. So dy over dx equals dy over du, then times du over dx. dy over du is just f prime of u, then du over dx is this one, so 2 times, bring the 5 to the x front, and the degree minus 1 is 4. So it asks you to find when x equals 2, what's the dy dx? So we are going to find the u value again. 2 times, sub in the 2 here, 2 to the exponent 5, give us 64. Then we sub this x equals 2, u equals 64 here to find dy over dx equals f prime of 64. So times 10 to the exponent 2 to the exponent 4. Then dy over dx equals f prime 64 is given negative square root 2 times pi, then times 10 times 2 to the exponent 4 give us 160. So we could just leave it in this way in terms of roots and the number pi, so we don't have to do the further evaluation. Okay, this is done. So this is how we do it. We find the derivative using chain rule, then we find the x value and the u value, then we sub back to find the derivative at x equals 2. So we have done several examples already. We continue the next example. We want to do the differentiate h at x. It means we want to find h prime of x. And in order to find this one, we want to treat it as a product rule. This is one product, this is another product. Then after we find the product, we need to use a chain rule to find a derivative to the base. So what we have done is we use the one that we have derived before is f at x equals n, then the dy dx equals exponent. We do it first. Bring exponent to the front, then exponent minus 1, then do the derivative to the base is f prime of x. So we are going to use this one for each factor of the product. So it equals the first thing derivative. So first thing derivative, we use this one, bring the exponent to the front. Then exponent minus 1, the base doesn't change at this point. And after that, we need to do the derivative of the base. So this is the base, x squared plus 3, the derivative give us 2x. Then this is first term derivative, copy the second term here. We don't touch it. Then plus, we copy the first term, then do the derivative to the second term. So exponent to the front, then exponent minus 1. So 3, the base doesn't change. Then exponent minus 1 is 2. Then times the base derivative, 4x minus 5, the derivative is 4. Then it didn't say simplify, so it's done. When it is marked, it will be the first derivative right, then plus second derivative right. So it will be, and you have the whole thing, the form is right. So these two, we don't change, then 3 marks. So this is example 6. You could pause the video and try the next one. Example 7. So differentiate this one. This is a division. You could use quotient rule, or you could change the denominator to multiplication. Then you change it to the product rule. So it's just which one you like, then you do it. So this is a quotient rule, but also you could change it to product rule. So times, we change the quotient to the negative 1 or 2, then it will be a product. So which one you like, then you just do it. I will practice on the quotient rule. So this is a u divided by v prime. So for this one, the quotient rule is denominator squared, first come, first derivative, u prime v. Remember it's minus uv prime. Okay, so this is our quotient rule. And this is u, this is v, and after u, you need to du dx, dv dx, continue. Okay, So f prime of x equals denominator squared. Then first come first derivative, so x minus 1 derivative is 1. Then copy the denominator here. Then minus numerator here, then denominator, we are going to use a chain rule. So this is 2x squared minus 1 is 2x squared minus 1, square root is 1 over 2. So this is a power rule first. Bring the 1 over 2 to the front. Then 1 over 2 minus 1 is negative 1 over 2. Then don't forget, it's chain rule. You need to do the derivative to the denominator. 2x squared give you 2 to the front. Then this one minus 1 is 2 times 2, x1, so it's 4x. And you just simplify a little bit. So this is 1 times is, don't change, just square root 2x minus 1. Then 1 over 2 times 4 give you 2. So we put the x at front, x bracket, x minus 1, multiplication order doesn't matter, then 2x squared minus 1, negative 1 over 2, all over squared, square root, they are inverse function, they cancel out. We only have 2x squared minus 1 left. So that is all for this lesson, and this is all for chapter 2. Thanks for watching. The assignment work is on Delta Math. Thank you. And if you couldn't access Delta Math, or you just want to do the work in PDF version, please, after you got the PDF version question done, submit it to Dropbox. Thank you. Thanks for watching.